In this video, we are continuing in Unit 3 of our Pre-Calculus OER course. And in Section 3.4, we will review the trigonometric functions of angles on the unit circle. The unit circle has a center at the origin, which is the point 0, 0, and it has a radius equal to 1. So if I look at a graphing grid, a common one that we use for our tests. Let me see if we can get one. There we are. I have zoomed in enough. So the center here is at the origin, and then the radius is equal to 1. So I'm going to go 1 unit to the right, 1 unit up, 1 unit to the left, and 1 unit down. And this will be the graph of the unit circle. And of course, when we are in a regular view, the unit circle is really small. So what we do usually is we zoom in to ignore the, 20 by 20 grid that we usually provide for graphing. And instead, we just zoom in all the way into the center of our Cartesian coordinate system. So this is the 0, 0 point right there. And then the 4 points indicated when we were sketching the graph were the rightmost point with coordinates 1, 0, the top point 0, 1, the point on the left -1, 0, and the point in the bottom 0, -1. So these are the 4 points that I used to sketch the circle in the Cartesian coordinate plane. In terms of rotation, they correspond to angles 0 degrees, 90 degrees, 180 degrees, and 270 degrees. And then the 0 degrees also comes back to be 360 degrees as well. Now, when we are on the unit circle and we have a random angle, let's say here, with coordinates x, y, on the point on the terminal side, I will pick to be a point on the circle. I will do that because the radius will equal to 1. Then from the definition of trigonometric functions of any angle, the sine will be y divided by r, but r is equal to 1. So I will have sine equal to y divided by 1, which is y. And the cosine will be x divided by 1, which is x. And the tangent will be y divided by x from the regular definition. And the cosecant will be 1 over y, because r is equal to 1. The secant will be 1 over x, and the cotangent will be x over y. And you see again in our formula packet, when we have the circle, that this is exactly what is happening here. We have points on the circle, and these points on the circle have 2 coordinates, a horizontal coordinate and a vertical coordinate. And the first coordinate x is the cosine, and the second coordinate y is the sine. And the reason that these coordinates correspond to the sine and the cosine is because the radius of the unit circle is equal to 1. You can also see on our packet these particular 4 key points corresponding to multiples of 90-degree rotations. So from this unit circle, we can now discuss trigonometric functions for the multiples of 90 degrees. So when we are at the point 1, 0, the sine is the y coordinate, the cosine is the x coordinate, the tangent is y divided by x, 0 divided by 1 will be 0, the cosecant is 1 over the sine, 1 over 0 is undefined. Division by 0 is undefined. The secant is 1 over the cosine. 1 over 1 will be 1. And the cotangent will be x over y. 1 divided by 0 is also undefined. When I am at 90 degrees, I'm at the point 1, 0, and at the point 1, 0, the sign is the y. I'm at the point 0, 1. And when I'm at 0, 1, the sign is the y-coordinate, which is 1. The cosine is 0. The tangent is 1 divided by 0, which is undefined. The cosecant is 1 over 1, which is 1. The secant is 1 over 0, which is undefined. And the cotangent will be x over y. 0 divided by 1 is 0. When I'm at the 180 degrees, I'm at the point -1, 0. And at -1, 0, the sine will be 0. The cosine will be -1. The tangent will be 0 divided by -1, which is 0. The cosecant is 1 divided by 0, which is undefined. The secant is 1 divided by -1, which is -1. And the cotangent is -1 divided by 0, which is undefined. When I am at the 270 degree rotation, I'm at the point on the unit circle, 0 with -1. The sine is -1. The cosine is 0. The tangent is -1 divided by 0, which is undefined. The cosecant is 1 over -1, which is -1. The secant is 1 over 0, that is undefined. And the cotangent will be 0 divided by -1, which is equal to 0. And remember that the trigonometric circle, the unit circle, is actually given to you. So if you have angles that are multiples of 30 degrees or 45 degrees, you can actually locate them on the trigonometric circle and just use that instead of trying to use your calculator or any other resources, because the trigonometric circle in your formula packet actually gives you the exact answers. So if I am at 150 degrees, let's call this point A. Point A will be right here. Remember that from our packet, right? Cosine of theta will be your x-coordinate and sine of theta will be your y-coordinate. So I will have that the cosine of 150 degrees is the first coordinate of that point, which is -√3 divided by 2. The sine of 150 degrees will be the y-coordinate, which is +1/2. And the tangent of 150 degrees will be y divided by x. So 1/2 divided by -√3 divided by 2. The denominators of 2 are simplified. I end up with 1 over the -√3. And if I rationalize denominators, -√3 divided by 3. And I will not do the 315 degrees because it is also on the circle, so I will let you work on that. Let's try one of the other angles. So let's try -240. So -240 will go in the negative direction. It will be -180 here, and then I need to go another 60 degrees. So in red here, I'm going to mark the -240. It's coterminal with the angle at 120. So I will have the cosine of -240 be the first coordinate at 120, which is -1/2. The sine at -240 will be the second coordinate of that point at 120, which is √3/2. And the tangent at negative 240 to be y square root of 3 over 2 divided by x, negative 1/2, and that will be negative square root of 3. Let's also do 600. The 600 degrees, let's call this point C. Let's try to locate it on the circle. So it has to be a positive rotation, so I'm gonna go in this direction. When I do a complete circle, I will be at 360 degrees. 600 minus 360. In my calculator will be 240 degrees. So I will be here at the 240 degrees. That's the coterminal angle. So the cosine of 600 degrees will be the first coordinate, which is negative 1/2. The sine of 600 degrees will be the second coordinate at 240 at negative square root of 3 over 2. And the tangent at 600 degrees will be y, negative square root of 3 over 2 divided by x, negative 1/2. The 2's will go, and it will be negative square root of 3 divided by negative 1, which is the square root of 3. Let's use the unit circle now to work with angles in radians. And again, I'm not going to do the 5 pi 6 and the 3 pi quarters, and that is because these are actually shown on the circle here. 5 pi 6 is at 150 degrees, so right there. I will let you work on that. And 3 pi quarters is at 135 degrees right there, and I will let you work on that. But instead, what we can do in this video is try to find where is negative 4 pi thirds and where is negative 11 pi quarters, and identify the sine, cosine, and tangent for those angles. So I want to find where is negative 4 pi thirds. I'm going to go in the negative direction. The slices of pi are thirds. That means I need 3 of them to go half a circle. So when I am at 180, I will be at negative 3 pi thirds. And I need another negative pi thirds, which will land me 60 degrees away from 180 in quadrant 2. So I am at the point, let's call this point A. I'm at the point of that is coterminal with 120 degrees. Therefore, the cosine of negative 4 pi over 3 will be the x-coordinate of that point, which is negative 1/2. The sine of negative 4 pi over 3 will be the y-coordinate, which is positive square root of 3 divided by 2. And the tangent of negative 4 pi over 3 will be the y-coordinate divided by the x-coordinate. The denominators will simplify. Square root of 3 divided by negative 1 equals negative square root of 3. My next endeavor will be to find negative 11 pi quarters. So let's call this point B. So the slices now are fourths of pi. Again, I have to go in the negative direction this way. At 180, I will be at negative 4 pi quarters. At 360 here, I will be at negative 8 pi quarters, and I need 3 more pi quarters. So 1, 2, 3 will land me at a coterminal side of 225 degrees. And for that, I can find the cosine of negative 11 pi quarters will be the x-coordinate, and that will be negative square root of 2 over 2. The sine of negative 11 pi quarters will be negative square root of 2 over 2 also, which is the y-coordinate. In the tangent of negative 11 pi over 4 will be the y-coordinate divided by the x-coordinate. They are equal to each other. Therefore, they will simplify and the answer will be 1. And for our last example, we want to use the unit circle to find all the trigonometric functions for the angles 90 degrees, -60, and 990 degrees. I will let you work with 90 degrees. It is at the point 0,1. We actually found that in our notes just a few minutes ago. -60 degrees will be at the point coterminal with 300 degrees. And what we can do together is look up where is the location for -990 degrees and then try to find all of the functions. So -990 degrees is -11 times 90 degrees. So if I start here and I move into the negative direction, the first bottom point here will be -1. This is -2, -3, -4 times 90 degrees. 5, 6, 7. This will be again -8 times 90 degrees. -9, -10, and -11. So point A is -990 degrees, and therefore finding the trigonometric functions of 90 and the trigonometric functions of -990 is the same thing. The point is 0,1. So I will have the sign of -990 will be the y coordinate. The cosine of -990 will be the x coordinate. The tangent of -990 will be y divided by x. That's undefined. The cosecant of -990 is 1 over y, which is 1. The secant of -990, let's not forget the units, these are degrees, is 1 over x, which is undefined. And the cotangent of -990 will be x over y, 0 divided by 1, which is equal to 0. And this is how we use the unit circle that is provided to us in our formula packet.